Welcome to a video from Bosch Rexroth. And today I would like to show you how to configure FSOE failsafe over EtherCAT, that is the exchange of safe data between two Control-X safety controllers. In the video Control-X Safety Part 1 Functional Exchange, I explained the functional exchange, i.e. the exchange of non-safe data. I start also this time with Control-X Works. And my control has the IP address 192.168.1.1. The user is Bosch Rexroth. And the password is also Bosch Rexroth. Again, the hint to choose a secure password for own projects. So, the programs for the I/O configuration and for the PLC program I take over from the predecessor video. To this, I start now the Control-X I/O configuration. Because now we need to extend it with FSOE objects. The program is opened on the second monitor. Here we see the created objects from the last time in video 1, and we must, when we make FSOE, also define a FSOE master. I'll determine that one now. This is the control with the serial number 204 at the end. That means I now select the object I want to communicate with. The Control-X safety needs 12 bytes in and 12 out. This is what I select now. This is the FSOE master connection. And the second control should be my FSO slave connection. I select this now. Here I have now also no more selection, but also here the 12 byte in and the 12 byte out. The new configuration is now loaded into the controller. If we look at the state now, we will find an invalid input configuration in the bus overview. The process data have been extended on the EtherCAT master side by the FSOE data. This must now also be carried out on the Control-X safety engineering side. The programs for this are already open in the background. This is the program for the FSOE master, with the serial number 204 at the end, and I now plug in the USB cable into the first controller. So, the cable is plugged, and now I extend the program for the FSOE communication. I select the slave device from the library with which I want to communicate. I find it under Slave Device, I/O and Bosch Rexroth. And here I find the object. So I want to exchange data with another controller. Here I go to the properties. I have to select the profile that I need for this. There is only one profile available. I select it now. Then I have to select a slave address. This should be the FSOE slave address 10. That's all I need to set. The rest can stay with the default settings for now. We will adjust the FSOE watchdog time later. And by enabling these settings and adding this slave, an object has been added here on the left side in the configuration that I can now use. For programming, I add another sheet. I'll rename this to Sheet FSOE. And here we also see that this object now needs to be used because of the green arrow. And I'll now drag and drop that into the editor. This object has many inputs, 96 pieces in total. I cannot configure the number. I have to take the object as it is. But then I want to use at least the whole editor. And that's what I have done now. So for a simple test, I will use the emergency stop signals already used for the functional exchange. There are already 3 terminals there, and I use these now also here. That means I now take the terminals and wire them with the inputs. So I send the signals to the FSOE slave. In the previous video, it was explained how the functional exchange with the Control-X core works. The programs were the same for both SafeX, but from now on the programs differ. I expect now from the FSOE slave also 3 emergency stop signals. These can then be used. For this I use now also here a few terminal ins. And I know that this signal comes from the FSOE slave. This is also a signal like emergency stop one. To distinguish the name, the serial number of the controller is also added. This is then the name. I now copy this to the clipboard because I need this name also for the other emergency stop signals. And I wired them now first of all. And from video 1 we learned that what is marked in red is not yet compilable. So I still have to use those signals. That means I'm going to send these signals to a logic again. But I make this very easy for myself and just take a dummy block here. So, that would be now already the FSOE master program. For a simple representation, how the whole thing works, such a program is already sufficient, so that I load the program now into the control. For this I go again on the device interface. Here again a short hint. Under connection settings there is the possibility, in case you have several USB COM interfaces, to select the suitable one here or also to make a configuration via Ethernet. I close the window again. And I connect to the controller. And send the program now to the controller. I lock the configuration and I am actually done with it now. The LED of the FSOE master control is still flashing yellow. This state indicates that the FSOE communication is not yet working. But what we can check. I switch to the Control-X IOA configuration, which is still active in the background, and switch again from init to OP. And here we see that the I/O configuration for the FSOE master is now correct. Next we have to do the FSOE slave configuration also on the other SafeX. This is what we do. This is now the open program of the SafeX 214 at the end. For this we first go to the controller itself and have a look at the properties, and to activate the FSOE communication, we have to activate the slave network. We do that here via this checkbox. And by activating the checkbox, a new object has been created here. We do not need to do anything else here. We select the new object here and have a look at what we have here for properties. And here are some possibilities, also for the secondary interface. But this is only interesting if Profinet or ProfiSafe is used. Now we select the protocol, and that is FSOE. These are now default values of these 96 bits. We don't change anything at the moment. And take the FSOE address, which we have set for the slave on the master configuration. This is the address 10, which can remain, so that we can change now already times into the programming. So we change to the functional scheme and make a new sheet here as well. We also call this FSOE. And now we look into the library, what has changed there, and here now new objects have been added. These are also colored yellow. These are the functional input and output that we are already using in this project now. And here we have new objects that are for secure data exchange. Let's start with the FBus output, which we now send from the FSOE slave to the FSOE master. And we want to send 3 signals. Here we can set that. And these should now also be the emergency stop signals. Now we need the object FBus input. These are the inputs that the FSOE master sends us. There are also 3 of them. Then we do it like in the other program. We take terminal in for it. And have a look at the properties. Now change the name. That means, here I only have to specify the source of the signal. I copy this now again into the clipboard for the other signals. That is, these are the signals that come from the Control-X Safety 204 at the end. So now still connect. We see there is still some red. This means that I also have to put these signals on a dummy block. Okay, now we can compile the program. You don't really have to do that, because it will be compiled automatically before committing. And in case it is not compilable, you could not transfer it either. To connect to the controller, we have to select the device interface again. Now we connect to the controller. To do this, I must now reconnect the USB cable. Enter the serial number and transfer the configuration to the controller. Then we close the configuration. I switch to the Control-X IOA configuration, which is still active in the background, and switch again from init to OP. And now the EtherCAT configuration is correct. Both Control-X Safety have the state OP. But the FSOE data are not transferred yet. I load now the I/O configuration into the control, and I change to the Control-X PLC engineering. To do this, I switch back to the core web interface. Here I start the Control-X PLC engineering. Here in the data layer, the FSOE objects are not contained yet. But we need them here. Therefore, we have to update the whole thing now. That means, we go to edit again and insert the new data. And now we see here the new objects for the FSOE connection. This is now the object for the FSOE master. And here is the object for the FSOE slave. So that the video does not become too long, I prepared a little something. And that is a part for the declaration. I copy that to the clipboard and go into our PLC program and copy the declaration I need in here. So, what do I have here? I have here a byte array of 28 bytes in total which are on addresses. These addresses still have to be checked. We are now looking at the FSOE master declaration, which means that we will first go here and take a look at where the data begins. This is at address IB0. And this is the opposite direction QB0. So that fits. Now let's go back to the PLC program. IB0 and QB0, those are also the addresses where the arrays are addressed. Now the opposite direction. The FSOE slave data start at IB74. And the opposite direction at QB94. That's fine too. That means we can leave it like that. Here the complete packet of FSOE data is mapped. The FSOE master packet starts e.g. with a FSOE slave command byte, then comes 2 bytes of user data, then again the FSOE slave CRC etc. and some other information. So the mapping of the data from the FSOE master to the FSOE slave and the opposite direction is done in the PLC program. For this I change again to my prepared program and copy the data into the program code. The whole thing is done here by 2 lines. In these lines the whole array is copied, in this case the FSOE master inputs to the FSOE slave outputs and reverse, so we can compile the program now. Since there are no errors in the compilation, it can be loaded into the controller and start the PLC program. We see now that on the master control and also on the slave control, both LEDs are green. If the FSOE communication would not work correctly, we would still have a yellow blinking LED. This is not the case. Let's have a look at the FSOE data, and here we see 3 set bits. This looks good here as CRC newly formed in each FSOE cycle. Further data are not transmitted as user data. Therefore we go now again on the Control X safety and activate here the diagnosis. I am now on the right control with the serial number 214 at the end, so if I now actuate inputs on the left control, I should see them here in the area. I'll do that and take away the 3 signals. And you can see that the signals have actually disappeared. Then I add them back. That is, the FSOE communication is working between the two controllers. That's what I wanted to show you. Thank you for watching this video. I hope it was helpful for you. If you have any comments or suggestions, please comment them below. Enjoy Control X automation and be 2 steps ahead.